As I promised, this video is going to show you how to find the cross product when your vectors are given to you using unit vectors. As a reminder from class, we talked about the cross product of two vectors and found that if we wanted to find the magnitude of the cross product of two vectors, like say A cross B, the magnitude of the cross product could be found if we know the magnitude of A, the magnitude of B, and then the angle between the two, which we called phi. This would tell you how large the cross product is. The right-hand rule would give you the direction. However, this situation is good if we have something like this: vector A, vector B, and the angle between them. But what if vector A is given to us in the form of unit vectors, and vector B is as well? How do we find A cross B? Well, let's see. Alright, so just to remind you, vector A was given to us as 3i plus 5j plus 3k. And vector B is given to us as minus 2i plus 4j plus 2k. What is A cross B? Well, it turns out that we can find A cross B by finding the determinant of this matrix. The matrix is found by taking the top row are our unit vectors. The components of vector A, which is the first vector in the cross product, makes our second row. So we have 3, 5, and 3. And vector B's components make the last row, which is minus 2, 4, and 2. So this means the determinant. This might be something that you've done before in one of your math classes. Now, it's kind of easy to find the determinant of a 2 by 2 matrix. The 3 by 3 matrix you may or may not have done. There's different ways to do that. But one of the ways that we can find the determinant of the matrix is by expanding about one of the rows. So what we're going to do is we're going to talk about how we expand about a row. We're going to expand around the top row. And what that means is those are going to be the coefficients. This is what I mean. So first, in the top row, we have I hat. Now, I hat is found by eliminating the column and the row that I is in. What remains is the matrix elements that we have. So it's 5 and 3 and 4 and 2. Then our next element is J, right here. So we have J, J. And now for the matrix that J forms, we eliminate the row and column that J is in. And that leaves us with 3 and 3 minus 2 and 2. And hopefully you can see what we're going to do with K. We eliminate the row and column that K is in, and the remaining 4 numbers are our 2 by 2 matrix. So it's 3, 5, minus 2, and 4. And so remember that finding the determinant of a 2 by 2 matrix is easy. We multiply the numbers going diagonal like this, and then we subtract the diagonal product in the opposite direction. But before I go on, there's one more thing I want to talk about, and that's signs. in the matrix, every element has sort of a cofactor, which is the sign. The way it goes is it's positive, negative, positive, negative, positive, negative. And so when we were expanding around the top row, these signs also come along. So we have positive times I hat and then the 2 by 2 matrix. But what we have for the J is there's actually a negative sign. And so it's K also has a positive sign, so it's just a little trick that we have to remember, this negative sign for the J component. So now we're going to find the determinant of each of these matrices. The determinant of the 2 by 2 matrix will then tell you the component or the magnitude of each of these components. So in the X direction, or the I hat, we get 5 times 2 minus 4 times 3. Then we move on to the Y component, and we have 3 times 2 minus 3 times minus 2. And then finally, for the Z component, we get 3 times 4 minus 5 times minus 2. And so we just simplify. We get 10 minus 12. For the Y component, we get 6 minus a minus, so that's plus 6. And then in the Z direction, we get 12 minus a minus 10, so that's plus 10. And so our final answer is, in the X direction, the component of A cross B, the X component is minus 2, and then in the Y direction, we have minus 12, and in the Z direction, we have 22. So the answer is, for this, A cross B is minus 2I minus 12J plus 22K. And that is how we can calculate the cross product of two vectors when they're written in unit vector form.